Alright, as we continue on with exponents, we're going to have today power to a power and power of a product rules. So the first one is that when you have a base with an exponent being brought to another exponent, you are going to multiply those two exponents together, which is known as power to a power. Best way I can possibly explain that is to say, let's say we had x cubed to the fourth. Well, really what we have there is x cubed 4 different times, which we can use our old rules to tell us that's got to be x to the 12th, but 12 is also 3 times 4. Not a too complicated of a topic, so if we have, for example, m cubed and then broaden that to the 5th, that's simply m to the 15th. Or b squared to the 10th becomes b to the 20th. Just like we did with the other rules we've talked about, we have to throw in coefficients. So in this case, we're going to have to take 3 and x cubed to the 4th power. Well, 3 to the 4th power is 3 multiplied by itself 4 times, which is 81. And x cubed to the 4th is x to the 12th. Same thing if you have a negative exponent. Negative 5 squared is positive 25, and then a cubed squared is a to the 6. And the fact that we have coefficients now and there leads us to the other property that we have today, which is known as the power of a product. When you have two different things multiplied together and they're brought to an exponent, you can bring them individually each to that exponent. Power of a product. An example of that would be, say, x squared, y cubed, z to the 5th, all being brought to the 3rd power. Well, we're going to have to implement both rules here, power of a product and power of a power. So we're going to have to take them individually. So x squared cubed would be x to the 6th, y cubed cubed would be y to the 9th, and z to the 5th cubed would be z to the 15th. You can see that if we can add a coefficient, like we just did in the previous example. Negative 2 cubed is negative 2 times negative 2 times negative 2, which actually still gives us a negative, because it's 3 negatives make a negative, negative 8. That becomes x to the 9th, y to the 15th. And a reminder, there is a big difference between negative 2 squared and negative 2 squared. This is what, for example, equals 4. This equals negative 4. You have to be very careful when you put that in a calculator. That if you do 10 and take the entire term and put it into a square, you're going to have to put parentheses, or the calculator will recognize it as negative 4. And one final example that incorporates all of the rules we just discussed. So, we're going to have to take each individual parenthesis, bring them to their respective powers, and then combine them together. So, 3 squared is 9, a cubed squared would be a to the 6, b to the 4th squared is b to the 8th, again we're using power to a power right now, and c to the 6th squared would be c to the 12th. Multiplying that by negative 2 cubed, which we just said in the previous example was negative 8, a to the 6th, b to the 15th, and then 1 times 3 is still 3, and coefficients multiply together. But now we go back to our previous property. When we're multiplying variables that have the same base, we're going to add their exponents together. And that, my friends, is all she wrote. Next thing we're going to discuss is negative exponents. That'll be in the next segment.